Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Different Sum Whisper Loop by Yitrio, and here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9, such that there are no repeats in any row, column, or designated 9-cell regions. We have to draw a 1-cell wide loop of orthogonally connected cells. The loop may not touch itself, not even diagonally. So, as an example, we could have a loop like this. And what does it mean to be orthogonally connected? Another way of saying it is basically every cell on the grid must share an edge with exactly 2 other cells on the loop. And if it shares a corner with another cell on the loop, they are either neighbors or they share a neighbor. So this is a valid example because every cell on the loop shares an edge with exactly 2 cells on the loop, and if they share a corner, they are either neighbors or they share a neighbor. What would not be valid is something like, how do we come up with something valid or something? What if we had this? This would not be valid because these 2 cells share a corner, but they do not share a neighbor, and they are not neighbors on the loop. So this is why that would not be valid. You could not have something like, even if you remove that, you could not have something like, say, you could not have something like this, because this would be essentially touching itself orthogonally. And again, this would share an edge with 3 cells on the loop, which is not allowed, right? So if it went something like this, going this way, technically that is possible as a loop, but in this specific case, you can't have it touching itself, which means basically going to another cell that shares an edge with it, while not being directly going from that cell. Anyways, those are examples of what can and cannot work for the orthogonally connected 1-cell wide loop, which may not touch itself. The loop acts as a German whisper line. That is, adjacent digits on the loop must have a difference of at least 5. Or as I like to call it, a whisper 5 line. So for example, if this were the loop and this were, say, a 3, these 2 digits would have to be 8 or 9, because the only digits which are 5 or more away from 3 are 8 and 9. And that's an example of how German whispers works on this loop. The loop must enter every cell of every cage. So, for example, basically, this is not a valid loop that I have here because every cell in the cages are on the loop. Digits may not repeat within a cage, and the sum of all digits in a cage is its cage sum. And this cage sum is different for every cage. So that means the sum of this cage must be different from the sum of this cage, which is different from the sum of this cage, this cage, this cage, this cage, etc., etc. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, let's color each cell on the loop as on the loop. This cell can only enter this way and exit this way, so those must be on the loop. This cannot be on the loop because it would be considered touching itself. It must go there. It must go to here. One of these is on the loop, one of these is off. One of these is on the loop, one of these is off. Same with this. Okay. So, for sums on the loop, or for sums in the cages, you're going to have one low and one high for the sums. So the low can be as low as 1 and 6, which adds up to 7. And then you can go as high as 4 and 9, which is 13. Right? Because you're guaranteed a low digit and a high digit on a Whisper 5 line. If they're adjacent, because the digits 1 through 4 have to be next to 6 through 9. 1 can only be next to 6 through 9, 2 can be next to 7 through 9, 3 can be next to 8 or 9, and 4 can be next to 9. But you're guaranteed, essentially, for next to a low digit, you have to have a high digit, and next to a high digit, you have to have a low digit. So you're guaranteed 7 at minimum. You have up to 13. You have 1, 2, 3, 4, 5, 6, 7 different 2-cell cages. That means, let's do this high and low. So then this should be essentially gray instead of blue. So you have 7, 8, 9, 10, 11, 12, and 13. Those are the 7 different sums you can have for 2-digit numbers on a German Whisper line that are adjacent to each other. So one of them has to be 1, 6, the other one has to be 4, 9, and then you have everything else in between. So that possible combinations are 1, 6, 1, 7, to add up to 9 could be 1, 8, or 2, 7. To add up to... Right, to add up to 9 is 1, 8, and 2, 7. To add up to 10, you have 1, 9, or 2, 8. 11's 2, 9, or 3, 8. 12 is 3, 9, and 13 is 4, 9. So the possible combinations you could have for the 2-digit cells. You have to have 1 and 6. So you have 1 and 6 for 7, 1, 7 for 8, 1, 9, or 1, 8, or 2, 7 for 9, 1, 9, or 2, 8 for 10, 2, 9, or 3, 8 for 11, 3, 9 for 12, and 4, 9 for 13. Interesting. Okay. You cannot have... So these singleton cells, you have... Say this was high, then this would be low, high, low, high, low, high, low. These are opposite cells. So the thing is, okay, so since the loop can only go orthogonally, you cannot go diagonally. That means you'll always alternate between low and high digits. One set will always be the same. You have low, high, low, high, low, high, low, high, low, high, low, high, right? So these are opposite sets no matter what you have. Well, that means one of them has to be a high digit and one of them must be low. That means for the high digit, we already have 7 through 9 accounted for, because those are the 2-digit sums that you can have. 7 through 13. And we have 7 different ones, so therefore that accounts for all the different sums. Therefore, the high must be a 6 lift. 6 cannot be next to 2 unique digits on a whisper 5 lines, so this must be the high here, and this must be low here. Low is next to high, which is next to low. And this is just something that occurs when you have a loop, right? Everything on the loop that is on the loop, if they alternate between sets, it can only be one set. It can't be the opposite set because it always goes or moves orthogonally. So to get to this cell, it has to go high and low, right? No matter how it goes. So it could go high, low, high, low, high, low. It will always be lows, right? So these will always be highs. These will always be lows. So these are both lows. These must be highs. So this is high, high, and high, right? This would be high, low, high, low, high. So this is low. These are lows. These are highs. So this is a high. This is a low. Low, high, low. High. Low, high, low. And this is high. High, low, high, and low here. So the highs will be on the same diagonals, so will the lows, right? So this has to be a 6 here, which means it must be next to a 1 in one direction. So there has to be... So these again, so one has to be one of these two. I guess it could be 1, 1, no, because one of these two must be where these connect, because otherwise they would be considered touching each other diagonally, because they would not share neighbors. So one of these, though, is guaranteed to be 1. One of these has to be a 1. Since this is a 1... this has to be 7, 8, or 9. This can't be 1, so this is 2, 3, or 4 here. As a low digit, this could be any of them. It's 1, 2, or 3. We are guaranteed there's a 4 in one of these cells. This cannot be 4, because either way the loop goes, if it goes this way or it goes this way, this shares an edge. This will be next to 2 unique digits on a whisper 5 line. Same with this. Either way, if it goes this way or if it goes this way, these are 2 unique digits on the whisper 5 line that this is next to. So this has to be 1, 2, or 3. Therefore, in box 1, what is the last low digit? It must be 4. So then this must be 4 and 9. That's the 13. It must be next to another 9. It cannot be 9 here, so it has to have a 9 either here or here. We don't know. Okay, so if it goes this way, the problem is that it connects to here, but how does it connect to both here and here? It can't. So it cannot go this way, because if it goes this way, then this must continue on to one of these 2 cells to connect. But if it goes this way, that's 3 cells that are on the loop. This cell shares an edge with 3 cells that are on the loop, which is not allowed. If it goes this way, then you have problems here, right? And then this must go this way, and then these will touch diagonally. That's not allowed. So this cannot go this way. This has to go this way and is 9. These must be 7 and 8, so this cannot be 3 here. This is 1 or 2. It cannot go this way because it would be considered touching itself. It can't go this way because that would be considered touching itself. Same with this. This must go out this way. This cannot be 4 and 9 because we already have the set that adds up to 13. So this is not 4. This is 2 and 3. This is next to 2 unique digits on a whisper 5 line, so it's 7, 8, or 9. We have a 5, 6 pair here because the remaining digits in this box we have a 1, 2, 3 triplet and a 7, 8 triplet. Okay. 9 cannot be here. So it's 7 or 8 here. This is 6. We need a 1, 6 somewhere. This can't be... Oh, this could actually be 6 here. This cannot be 6. It would be next to 2 unique digits on a whisper 5 lines. So this could be 6. This could be 6. So we know in column 1, we have a 1, 2, 3 triplet, and 1 has to be in one of these 2 cells. So this is definitely 1, which means this cannot be 1 here. This is 2 or 3. One of these is low. It must be next to 1. This cannot be 6. It's next to 2 unique digits, so it's 7, 8, or 9. This is next to 2 unique digits, so it can't be 9. It's 7 or 8. The remaining digits in this row have to be 1 through 6, because we have a 7, 8 pair and a 9 in that row. This is 6, 7, or 8. This could be 6, 7, or 8 here. We have 9, 4. Only one of these can be 9. So one of these two has to be the 3 that corresponds with that 9. Because this can't be 9, this can't be 9, this can't be 9, and that can't be 9 for the high digit. So one of these is 3 and 9. We don't know which. That means we do not have 2 9 available. We have, or 1 9 available. So we have 4 9, 3 9, 3 8, 2 8, either 1 8 or 2 7, or 1 7 and 1 6. Interesting. We need at least 2 8s here. This has to do with 7 or 8. It could be 1, 2, or 3 here. That's fine. This is also 1, 2, or 3 here. Next, so all the lows have to be 1, 2, or 3. Okay, that's not that helpful. We do have a 1, 2, 3 triplet in row 1, which eliminates 1, 2, and 3 in the rest of the row. So that leaves the remaining digits as 4, 5, 6, 7, 8, 9. So this cannot be going low here because we have a 1, 2, 3 triplet here. And this is the low, would be 4, which would not be next to 9. So it cannot go this way. That means this must go high here. This again cannot be low because that's next to 2 unique digits on a whisper 5 line and can only be 4 there. So then this is low. This must be high going to low here. That connects to this. This can't be touching itself. Can't be touching itself. So this must go out this way. Oops. This is low here. Cannot go here, it would be considered touching itself. Can't go here, it would be considered touching itself, so it must connect this way. So then that's done. This goes this way. This can't be because it would be touching itself, so it must be high here, which goes that way. This can't connect because it would be touching itself. This can't connect because it would be touching itself diagonally there. None of these can be touched because it would be considered touching itself. So this must go this way then. And this is a 1. What was that? This is 1, so this cannot be 1 here, and this can't be 1 here. That means to be on the loop, it has to connect that way, and therefore is a 1. So this is on the loop. These are not on the loop because they would be considered touching itself. This is not on the loop. This can't be on the loop. This could be 4. So it's 1 through 4 here. This is next to 2 unique digits on a whisper 5 line, so 7, 8, or 9. This is not, well, could be 6 through 9 here. Okay. So this is a high digit. No 4, 5, or 6 because it's next to 2 unique digits on the loop. This is next to 2 unique digits on the loop, so it's 1, 2, and 3. We have a 1, 2, 3 triplet in this box 3, which eliminates 1, 2, and 3 in the rest of the box. So this cannot be 1, 2, or 3. This is 4 through 9. No 4 or 9. 5 through 8 here. Nine cannot be here because of 9 in the box. We have a 5, 6, 7, 8 quadruplet in row 3, which eliminates 5, 6, 7, 8 in the rest of the rows. So this can't be 5, 6, 7, or 8. It's 1, 2, 3. No 4, 5, 6. This is 1, 2, or 3. It's next to 2 unique digits on a whisper 5 line. So this cannot be 6. If this were 6, it would be next to 2 unique digits on a whisper 5 line, and so could not work then as a 6. One is here. We have 1 and this is 6 by itself. We need a 1 and 6. So either this is 6 and 1 or this is 6 and 1. We don't know which. This cannot go that way. It would touch itself there. Can't go this way, so this must go here. This kind of looks like a heart sort of shape here. Interesting. We have a 1, 6, a 1, 7, which we need. So we've got 4, 9. 1, 6, 1, 7, 2, 8, 3, 8, and 3, 9, and we have a 4, 9. So 3, 9 is one of these two. Okay. If this is 6 and 1, this cannot be 1 here, so one of these two would have to be 1 in box 2, which means this couldn't be 1. If this is 6 and 1, that means this couldn't be 1. So either way, this cannot be 1 here. Where is the 1 in row 2 then? It has to be one of these 3. So that eliminates 1 from the rest of the box, so this can't be 1. Um, hmm. Hmm. This digit cannot be 1, so it has to be 2, 3, or it cannot be 4. This would be basically sharing an sharing this edge with two unique digits here or two unique digits here. So this is 2 or 3. We have a 2, 3, 2, 3 pair in column 8, which eliminates 2 and 3 in the rest of the column. This is guaranteed to be 1, which means 1 cannot be here, 1 cannot be here. This can't be 3, 9 anymore. Where is the 3, 9 possible here? It has to be here. So this is 3, this is 9, which eliminates 9 here. This 3 has to be next to an 8 on a Whisper 5 line because it already has a 9 here. 8 eliminates 8 here. So this is 7. 7's next to both 1 and 2 on the Whisper 5 line. 7 eliminates 7 here, so this is 8. 7 eliminates 7 here, so this is 8. This can't be 8 here anymore. This can't be 9. So we have 8 here. Could be with 1, 2, or 3. That's fine. We have a 1, 2 pair here. This must be 3. So that eliminates 3 from being here. This can't be 8 anymore. Therefore, since this can't be 8, this can't be 3. It'd be next to the 6 or 7. That's there. So we have 3 and 9 here. This is 8 with 1, 2, or 3. This can't be 8. This can't be 8. I guess this could be 8 here. This is next to two unique digits on a Whisper 5 line, neither of which can be 1. So this cannot be 7, therefore this is 9. There's no 9 here. So then this digit cannot be 3 because it would be next to two unique digits on a Whisper 5 line, neither of which can be 9. So therefore that can't be 3. We have a 1, 2, 1, 2 pair in box 3, which eliminates 1 and 2 in the rest of the box. Also, this can't be 8 anymore. We have a 5, 6, 7 triplet, which eliminates 5, 6, and 7 in the rest of row 3. So this can't be 7, this is 8. This is 8, which eliminates 8 here. This can't be 1 or 2 because of the 1, 2 pairs in the box, so this has to be 3. Since this is 3, it's only next to 8 or 9 on a Whisper 5 line. So this is 9, which eliminates 9 here. 3 eliminates 3 here, so this is 2. 3 cannot be here. Where is the 3 in row 3? It has to be this cell here. So this is 3. This is interesting. If this is 8, 2, that guarantees this is 7 and 1. So therefore, this would have to be 1 and 8 here. One of these is guaranteed to be a 2. So it must be next to a 7 in one of these spots, which means this cannot be 7. Also, yeah, we have a 4, 5, 6, 7 pair here. So this is guaranteed to be 7 here. Okay. If this were a 6 here, the problem with that being a 6 is it would have to be next to a 1, but then next to a 1 also on the other side. And it cannot be next to 1 here and 1 here, or 1 here and 1 here. So this can't be 6. So to have a 1-6 pair, it has to be in the cage, it has to be here. So this is 6, 1, which forces this to be 2. This 6 is next to a 1 here. 1 eliminates 1 here, so it's 2 and 1. 2 cannot be next to 6, so this is 7, which means this can't be 7. That's 8. This is 8, 2, and 1, 8, so this must be 8 and 3, which means this cannot be 3 here. This can't be 3 either. We're missing the sum adding up to 8, which is 1 and 7. So this has to be 7, and this is 1 here. Anyways, this can't be 6 anymore. This is not 6 or 8. No 6 or 8. No 1, 6. No 1, 6. No 1 here. Okay, so 7 has to be with 2. It could be either one of these ways with 2. 2 could go to 7 here. 2 could go to 9 here. 2 could go to 9 here. That's fine. Okay. This can either go this way to connect here or go this way to connect here. It cannot go this way. So none of these can be on the loop. This could go down here potentially. Okay, remaining digits in column, let's do column 8. We have 4, 5, 6, 7. Obviously 7 can't be here. Remaining digits in column 1. We have 4, 5, 6, 9. This can't be 6 or 9. Remaining digits in column 2. We have 2, 3, 4, 7. No 3 or 7 here. No 7 here. So we're guaranteed 6 and 9 here. And we're guaranteed 7 in one of these 2 digits here, and 3 in one of these 3. Remaining digits in column, we have a 2, 4 pair in row 4, which eliminates 2 and 4 in the rest of the row. We have 5 and 6 remaining. This can't be 6 because of 6 in the row or box. So this must be 5, and this must be 6. 5 eliminates 5 here, so it's 4. 4 eliminates 4 here, so it's 2. 2 eliminates 2 here, so that's 4. This can no longer be 4 here. This can't be 4 here. 6 eliminates 6 here and here. We have a 4, 5 pair in box 3, which eliminates 4 and 5 in the rest of the box. This can't be 5. It's 7. This can't be 5 or 7, so it's 6. 6 eliminates 6 here, so it's 5 and 6. Okay. Remaining digit in box 4 is a 7. Remaining digits, so this cannot be 2 here. This becomes 3, 4, and 7. This can't be 4 here. This is 5, 6, and 9. Okay, remaining digits in column 3 are 2 and 8. Okay. 7 here eliminates 7 here, so this is 5, which makes this 2. 5 eliminates 5 here, so it's 4, which makes this 5. This can't be 2 or 5, it's 4. This can't be 4 or 5, it's 7. Remaining digits in column 4 have to be 1, 3, 6, and 8. No 3 and 8 here, no 1 and 6 here, no 1 here, no 1 here. This digit cannot be next to that digit here because it's not 5 away from 7. So these cannot be on the line. It must go to here, high, and this low. So this is 2, this is 8. To connect to the 7. This has to be 1 because there's no other place for it in column 4. One of these is a 6. This can't be 8 here because of 8 in the row. These can't be 6 because of 6 in the column. Remaining digits of column 5, we have 2, 5, 6, and 8. No 8 here. This can, if this were high going this way, it would be 6 only. And the problem with that is it would be next to 2 unique digits on a whisper 5 line. So this cannot be on the loop. It must go this way. This cannot be 6, 7, or 8. It has to be 9. It could go this way, could go this way. That's fine. This cannot be 8 here on the rows. No 2 or 6. Remaining digits in row, or sorry, column 6. We have 2, 4, 5, and 7. 7 can't be here because of 7 in the box. No 2 here, no 7 here. Where is the 7 in column 6? It has to be here. So this is 7. This loop cannot loop back here because it would be considered touching itself, so these two are not on the loop. If this were on the loop, it would have to be low, but it can't be, so this can't be on the loop. If this were on the loop, it would have to be high, but it can't be high, so this is not on the loop. Remaining digits in row 5. We have 2, which none of these can be. Oh. 2, 4, 5, and 6. 2 and 6 cannot be here. Therefore, this has to be 6, and this is 2. This becomes a 4, 5 pair. 4 can't be here because of 4 in the column. So this is 5, that's 4. 3 here eliminates 3 here, so that's 8, which makes this 5. 8 eliminates 8 here. No, this can't be 5 or 6, so this must be 2. This can't be 2, 5, or 6, it's 8. There's no 2 here. This could be 4 if this is 9. Remaining digits in row 7 are 3 and 9. Sorry, row 6 are 3 and 9. 9 eliminates 9 here. Remaining digits in column 7. 2, 3, 8, and 9. This cannot be 2 or 9 here. This cannot be 2 or 8 here. This can't be 8. We have a 3, 9 pair in column 7, which eliminates 3 and 9 in the rest of the column. This can't be 3 or 9, it's 2. This can't be 3 or 9, it's 8. So this 9 cannot go this way. It must go this way. So this is not on the loop. It goes this way then, so this is high. So this has to be 4, which makes this 5. 4 is next to 9 on the loop, which means this can't be 9. That's 3, which makes this 9. So the 2 cannot go this way. It could go this way, potentially. This is 9 on the loop. This cannot be 4. So this is 5 or 7. This can't be 5. So if it tried going this way, the problem is that would not have a difference of 5. So it cannot go this way, which means it must go this way, which means it connects this way. So the rest of this are not on the loop. 2 is next to 7 then. So this is 7, this is 5, that's 4. 4 eliminates 4 here, so it's 3. This can't be 3 or 7, that's 4. This can't be 3 or 4, that's 7. No 5 or 9 here because of 5 or 9 in the row, so this is 6. Which makes this not 6, that's 5, which makes this not 5 or 6, that's 9. 6 eliminates 6 here, so it's 3 and 6. That leaves this digit as 3, this digit as 1, and this digit as a 6. And that's the solution. Yeah, fairly straightforward. You have to know some amount about how loops work. Particularly when they're alternating between different sets, which this is. And then that simplifies things a lot. I don't know how many people know about the loop set, right, where you alternate. it's kind of, it makes sense, so it's not hard to deduce, but it's something that you, unless you've done a lot of loop puzzles, you don't really understand that aspect. Mm. And so the break-in would be pretty hard if you did not know that, right? Because and then you have to have the differences, right? For on the loop in the cages. Yeah, I don't know. I'm not sure how I would classify this. Probably, to me, it's easy, right? Because I know all these things for the break-in. But I don't know how easy it is to break in if you don't know any of this. Maybe I would put this as challenging level. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.